void test get nth argument. I created a simple function int main, copy the function name, copy, paste it here. We call custom function and we pass 1.1, 2.2, 3.3, 4.4, 5.5. We called our custom function by passing 5 arguments. I will insert 0, 0. So in total 6 arguments. Now here template, type name, ALG, types. Whenever I use plural form, it is parameter pack. Void custom function. We associate ALG types, ALGs. We associate template parameter pack with function parameter variables, ALGs. Please note association. Here, context pair or index. I will define arbitrary index, for example 3, or argument. We call get nth argument by passing ALGs. We have to expand. Stream index. Currently, index is initialized with value 3. Argument. We print out argument. Now here, template or index, type name, ALG, type. This is a singular form, type name, ALG, types. This is plural form because this is parameter pack or get nth argument. Please understand that ALG type I associate with ALG, ALG types, ALGs. I associated ALG type with ALG, ALG types with ALGs. I will use parameter pack. Please remember the word associate or association between type and variable. Now here, index is not associated. ALG type is associated. ALG types are associated. If context pair index is greater than 0 because we are passing 6 elements by calling custom function passes parameter pack ALGs. So index can be 5, 4, 3, 2, 1. Else, in this case, index is 0. So 0, 1, 2, 3, 4, 5, 6 arguments for ALGs. Here, return, we are calling this function recursively. We pass ALGs. Please understand that we dropped ALG, the first parameter variable. We omitted ALG, only passed ALGs. Index is not associated. ALGs are associated. So we have to explicitly pass index. From this parameter variable list, we removed ARG in this recursive call. So we have to decrement -1. In this part, return when index is 0, we return ARG. Now scroll down. In function custom, don't forget we have to pass index. So from 6 arguments 0.0, 1.1 up to 5.5, we want to extract index 3 arguments. Index starts 0, 1, 2, 3, 4, 5. Since the index is 3, when we call get nth argument, we pass the 3. 3.3 should be displayed here. In the command prompt, dir cd 080 paradigm shift clang sdd c++17 shift.cpp ltbb oc.exe, hit enter. clsc. So in the custom function, the third argument is 3.3, like this. If we change it into, for example, 5, we build again clsc, the last argument. Please make yourself familiar with recursion. Let me tell you how to debug compile time programming. std tuple arguments, we pass argument and arguments. String, we display index, then we display arguments. Copy this, paste it here. With this, we build again. Initially, when this function is called, 5 is index. Then these are the arguments. 0 is ARG. The remainders are ARGs. We call recursively. We call this function recursively. Index is decremented by 1 and we removed the first argument but passed ARGs. This is the second step. At this point, when index is 0, we only have ARG. ARGs are empty, like this. Or if you want to, you can say argument ARG std tuple arguments ARGs. I say argument ARG arguments ARGs. Then argument ARG arguments ARGs. Now copy this, paste it here. Now we build again clsc. So this is ARG. This is ARG. These are ARGs. These are ARGs. When index is 0, ARG is 5.5 and ARGs are empty. Get nth argument is a typical conventional programming technique. In conventional programming, we associate ARG type with ARG or type with value. Our goal is to process ARG or the value, not the type or ARG type. In C++ compile time programming, we associate ARG with ARG type or value with type. We are not interested in the value, but we are interested in the type. Now scroll down, right before function main, template, auto, size, int, ins, auto, create, sequence, std, integer, sequence, int. We associate ints with the integer sequence. Don't forget, we have to expand SYCL. Size is not associated. Ints are associated. Sec is an instance of integer sequence. Int ins. We associate type. This is type with a value seq. We are not interested in value seq, but we want to create a new type. The new type is integer sequence ins. Creating a type integer sequence is our goal. The instance, this seq, is dummy to associate template parameter pegs with type. Now here, if context pair size greater than 0, else at this point size is 0, then we return an instance of this type seq. When size is greater than 0, return, we call it recursively. We have to pass an instance. This is a new instance. We insert size. It can be int. We haven't associated size with this type or function parameter variable. We have to associate size. We decrement 1 for next iteration. Now here, template, auto, size, auto, create, sequence, return. We call this function. We pass size. This function takes an instance of integer sequence. So it should be instance. With curly brace, we are passing an instance. Create sequence, we pass empty list. Initially, ints are empty. Now here, copy this, paste it here using create sequence t 댓글 type. We are calling this function here by passing this size here. In this configuration, create sequence calls this function. This function returns an instance of integer sequence, so it becomes a type. Using value returned by create sequence, the return value we create type. In the conventional C++ programming, we use type to process value. In the C++ compile time programming, we use value to create a new type. The roles of type and value are reversed in compile time programming. We need a new paradigm shift. Void test create sequence using SYCL1T. We call this type function and pass 10. This is type. Stream SYCL1T. This is type. SYCL1T. This is instance. And there. Copy this function. Copy. Paste it here. In the command prompt, we build again. 68. I made some stupid mistake. Cut. Paste it here. I made some stupid mistake. We rebuild. CLSC. Sorry, I made another mistake. Copy this. Paste. We have to return an instance. Here, insert size int. This and this is the same. We rebuild CLSC from 0 to 10. In the create sequence T, the range is 0, size. Size is not included, so we have to subtract -1. Now we rebuild CLSC. If we pass 10, a new sequence, sequence 1T, a new sequence type is created. This is type. Now let's learn how to do debugging for compile time programming. I will change this part, delete. Instead, I will decrement -1 here. Here, stream index colon sequence, and then copy, paste it here. Now scroll down. We are here. Start command prompt. CLS. We build again. Sorry, it is size. We build again. CLSC. We cannot see this message. This code, also this code, is never executed at runtime. Once again, this function, also create function, is never executed. For example, stream hello, what's up? And then we are calling this function. We rebuild. We cannot see this message. These functions never executed at runtime. Code is not generated. Now, here, auto sequence. We are calling this function. Stream, we have to provide argument, for example 10. I will change it and there. Instead of 10, I will put 5. Sequence, and there. Now we build again. CLSC. Now hello, what's up? So I will disable it. Also stream and there. We rebuild CLSC. We now call this function. This function calls this function. So initially size is 4 because we subtracted -1. Initially this integer sequence is empty. Then it calls recursively. Size 3 is size, then sequence 4, size is 2, then sequence 3, 4, size is 1, then sequence 2, 3, 4, size is 0, 1, 2, 3, 4. Please understand that we print sequence before returning. When we return, we put size. So this is correct behavior. After printing this message, this is returned. We put size. So this is correct. 0 is inserted at this line. As I said, this is compile time programming. So at runtime, we never need these. We create sequence to generate type. We build again CLSC. These messages never displayed, never executed. Please note that create sequence, these functions are created to create type. After debugging, namespace, hidden, we enclose in the namespace like this. Then we give hidden. End of namespace hidden. Now copy this part, copy, make demarcation, paste. It is create sequence reverse. This should be reverse. Then here cut paste. Also cut, paste. Also create sequence, reverse. Copy this name, paste it here. Now here, full, reverse, false, reverse, true, copy this, paste. It should be create sequence, reverse, else create sequence. Sorry, we can't do this. Here, template, auto, size, full, reverse, false, struct, STE, create sequence. Using type, 댓글 type, we use create sequence. Semicolon, copy, paste, size, true. Then copy this, paste. We don't need this. Then copy this, paste, reverse, type name, hidden. With this modification, I will copy this, paste. It is now true. 2, 2, 2. In order sequence. Reverse sequence. We build again CLSC. This is in order sequence. This is reversed sequence, or ascending order, descending order. Default is ascending order or in order. If we provide true, then we generate sequence in reverse order. Compile time code is very difficult to do debugging. I will disable this part, then re-enable. It is now hidden. I will copy once again, paste, reverse, sequence, create sequence, reverse, reverse, sequence, reverse. We build again, CLSC. We can do debugging. This is in order sequence. This is reverse sequence. Using this runtime code, I disable. We create compile time code. We used runtime code to generate data type. Please understand that I updated C++ extension library. Today is February 14th. I updated my C++ library extension. By double-clicking this link, you can download updated C++ library extension. If you are new audience to my channel, you probably have to watch episode 16 to install super powerful C++ library extension.